So section 715 has to do with radians. So we're going to be able to define this new word that we've never really talked about in mathematics before called radians. How to make an angle, how to talk about how to find a radian, and then we're going to convert back and forth from degrees to radians. So isn't that some exciting news? All right. So when it comes to radians, the question is how else can I measure angles? You can measure them by these things called radians. So it's no different than, I don't know, is 1 foot equal to 12 inches?
No.
Yes. It's the same thing, right? You're just writing that same measurement in two different forms. You're either writing it as 1 foot or you're writing it as 12 inches. So the same thing happens when it comes to angles and radians. So angles and radians, they're equal. They're the same thing. It's just another way of writing it is all that it is. Different ways, different applications, like different ways of writing things. All right. So let's talk about angles for a second. So if we wanted to make an angle, and these little things called the standard position, right, you're gonna, I can do lights. We have our X and our Y axes. And when it comes to drawing out our angles, we always kind of like start at the origin, right? And if we, oh, I don't want that guy. Start at the origin. And if we go down like this X axis, right, that is called our initial side. So in other words, it's where we start our angle. And then we're going to end our angle someplace. So just for the fun of it, I'm just going to make one up and I'm going to say we're going to go to right here. So since that is where I end, this side is called my terminal side. Right? So if you're in an airport, and you go to an airport so you can get on a plane, right? And the plane is not in the building, right? So the plane's got to be on the outside of the building. So you have to get to the end of the building before you can get on the plane, right? And so those are why they're called terminals, because you got to get to the end, right? And then when it comes to making our little angle, there's technically two angles that we drew up here. So I'm going to go this way, and I'm going to say that this is theta. So theta is a Greek letter. So usually you just kind of like draw like a 0 or like an O, and then you just kind of make a little swoopy in the inside for a little theta. And so this is drawing, this is when our angles, we call this in the standard position. And granted, in the real world, not all of our angles that we want to measure line up on that like horizontal x-axis, but we're going to keep these in the standard position so that way when it comes to doing some of our math problems, right? So we can have positive angles and we can have negative angles. So I'm going to draw a little guy down here. And kind of like drawing that same angle that we just drew up above. And if I go from my x-axis and I go counterclockwise, oh, let me get some more pages up here. Here we go. This is going to give me a positive angle. Anybody want to guess a degree for that? Yeah, we can call it a little theta in there if we wanted to. But what's the degree? What's a good guess? Right?
Like 135.
135, I like that one. So that's approximately 135 degrees. So when it comes to our positive angles, we go counterclockwise. Or I almost think of it like when you start by going up, right? Your curve where your angle's going up. If I drew that same setup, but now I start at the origin on my initial side, but I start by going down or clockwise and I come around, that's going to give me a negative angle. So we knew going positive wise that was 135. And if we go all the way around, we went how many degrees? 360, right? So if we do 360 minus our 135, we're going to get negative 225 degrees. And if you put those absolute values together, we end up getting 360, right? So when it comes to our negative angles, those ones are always going to go clockwise from that initial point. Not too bad. That's perfect, Mrs. Fish. Thank you. All right, and I think we're pretty good at measuring our angles, right? We've been playing around with that a little bit with the unit circle. So today we're going to spice it up a little bit, and we're going to talk about these things called radians. And radians is just another form of measurement, right? So if you want to write down the long definition of the radian, it's the length of the intercepted arc, and we'll draw a picture, arc divided by the circle's radius. So if we want to draw that or write that mathematically, so a radian is the length of the arc divided by the radius. So I'm going to draw a perfect circle. Ho, ho, ho. So definition of radius? Center of the circle to any point on the circle. Okay. So if I draw some little angle, here's a nice little angle, right? So we got a radius, right? And where's my intercepted arc? What do you think that is?
Where the two, like in between the two arrows.
Yeah, so intercepted is like where it's cut, right, or where it goes through. So our intercepted arc is this guy, right? And that'll give us our radian, which we usually, what do we want to use? We'll use beta. So to figure out that, remember how I said that angle or that radian are kind of that same way, it's just another way of writing it. So to figure out that measurement in a radian, it would be that arc length divided by the radius. Right? So if we just had a nice little cheesy circle, right? And let's say we had some angle, oh boy. some angle going through this guy. And I knew my radius was 6 centimeters and my arc was 15 centimeters. And I wanted to know that theta, or that radian. My theta would equal the length of my arc. What's the length of my arc?
15.
Yeah. Over my radius,
6.
6. Yeah. And we can just simplify that down to what? 5 over 2 radians.
And you just leave it like that.
And we just leave it like that. Yep. All right. So we've been messing around with these degrees when it comes to our unit circle. So there's got to be a connection between those degrees and those radians. So we're going to talk about that little relationship they have. All right. My ceiling doesn't cave in, right? So relationship between degrees, which we already know about, and these new things we're learning about, radians. So we know some things about a circle, right? If I had my initial side going this way, and I had an angle, and I went all the way around, how many degrees would that be? 360 degrees, right? And that radian has to do with that, remember that arc going around divided by the radius? So if I wanted to figure out the distance all the way around a circle, anybody remember what that's called? Starts with a C. Circumference. Anybody remember the formula for the circumference?
Circumference equals pi r squared.
That's area of a circle. 2 pi
2 pi
r.
r.
2 pi r, or the diameter times pi, right? So if I wanted to, figuring out my radian of that 360 degrees, right? If I went all the way around the circle, that would be my arc all the way around the circle, right? My circumference. And then by definition of a radian, it's that arc, which was all the way around, divided by the radius, right? So then our r's would cancel out. So if we go 360 degrees, we would have 2 pi radians, right? So let's see if we can figure out a couple more of these. If I wanted to know 180 degrees, so if my angle was 180 degrees, I want to figure out that arc length over my radius. So it's going to be half of the whole circle. So how many radians is pi going to be? Or 180 going to be?
1.
Yeah, 1, or you can just write it as pi radians. Right? Could we figure out 90 degrees?
Yeah.
What would 90 degrees be?
A quarter pi.
A quarter?
And a half.
It'd be a half, right? What would 45 degrees be?
A quarter.
A quarter, yep. So there's got to be a formula or something that we can use, because granted we can keep dividing by halves, but what about all of those angles in between? Betcha there's something. So let's say we want to start off by going from degrees to radians. So if I take whatever degree that they give me, and I times it by pi over 180, it's going to give me my radians. So let's pick an angle. Let's say, how about 30 degrees? Right? So 30 degrees to radians. Okay. So 30 times pi over 180. Okay. We can either write it out or you can go ahead and simplify it from here. 30 goes into 30 once. 30 goes into 180 6 times. So we're going to get pi over 6 radians. You can even do these with negative degrees. So if I had a negative 135 degrees and I wanted to switch that guy into radians, what am I going to do? Negative 135 times pi over 180. And we can simplify that down and get negative 3 pi over 4 radians. Right. So leave these as fractions. Don't turn them into decimals. It makes it a lot easier if you keep them as, and then don't multiply by pi. You can just go ahead and leave our little pi there. Right? Pardon me?
Where do you get the negative 3 from?
Because it was negative 135, right? So I'm multiplying by my angle times pi over 180. So it's going to stay negative. We could figure out the positive value for that one. You can do it that way as well, but we'll get to those little fancy parts a little later. So if we can go from degrees to radians, guess what else we can do?
Radians to degrees.
Oh, you want to know how to do those? Okay. Yeah. So going from radians to degrees. So now with us switching it, they're going to give us the radian. Yep. And it's just the opposite. So it was pi over 180. So now it's going to be 180 over pi. And that's going to give us our degree measurement. So let's say they gave us pi over 3 radians. And we want to switch that baby into a degree to know where that is on our nice little unit circle. So I have my radians. And what am I going to times my radians by? 180 over pi. Right? My pi's cancel each other out, and that's what we're looking for, right? 3 goes into 3 once. 3 goes into 180, 60. Multiply those guys out, and we get 60 degrees. And again, we can have negative radians. We could have negative 5/3 pi radians, and we want to switch that guy into degrees. So negative 5 pi over 3. What are we going to multiply it by?
180 over pi.
Yep, 180 over pi. We can simplify it. Our pi's are going to cancel. 3 goes into 180, 60. Oops. Negative 5 times 60 is negative 300 degrees. Right? So if we had our crazy little circle,
So is the degree ever going to be over 360?
it could, right? And then you would just kind of go around the circle and then come back through. Yep. So on our 60-degree angle, which was like right about here, right? That's going to have a radian measure of pi over 3. I should keep going back to him and filling them all in. So we filled in all of our angles, right? And we filled in all of our x's and y's. So that solid line had to do with our radians. So we can now go through our unit circle and we can fill in all of our degrees with the radians. Because what did we just figure out? We just figured out 60 degrees, right? 60 degrees was that pi over 3. So we can write that on that solid line. So now you'll have your degrees, your radians, your sine, and your cosine all filled in on that unit circle. Any other angle you want to do? That's on the unit circle? Just, yeah.
135.
135. Yep, we'll do it. Here, we'll just do it right over here. I think I get room. So if I have 135 degrees and I want to turn it into radians, the way I kind of do this is I have degrees and I want to get rid of my degrees, so that 180 degrees is going to go on the bottom. So my degrees cancel out, then I got pi on top. Right? So how can I simplify 135 and 80? Anything go into both of those?
5.
5, yep. 5's going to go into there, what, 27 times? 5's going to go into 180, 36 times? Anything go into both of those? 3. 3 goes into there, 9. 3 goes into here, 12. Anything more?
3.
Oh, yep, 3 and 4.
Yeah.
Anything else?
No.
Nope. So what do we got?
3 pi over 4.
Yep. So on 135, we can write in 3 pi over 4. So make sure we go through our unit circle and we have all of our degrees filled in. We have all of our radians filled in, all of our cosine, which is the x value, and all of our sines, our y value. Sound good? All right.